Hey kids, welcome to section 1.1, solving linear equations. Today's targets, you're going to learn how to translate verbal expressions into algebraic expressions and equations, and vice versa. And you will also learn how to solve equations using the properties of equality. Introductory stuff. Let's see, we got verbal expressions can be translated into algebraic expressions by using the language of algebra. So basically we're going to take words and change it to symbols and numbers and then go the other way. So example number 1, write an algebraic expression to represent each verbal expression. So we got 2 more than 4 times the cube of a number. All right, so more than means plus. 4 times means multiplication. The cube of a number is a little 3. So if I want 2 more than, I'm going to do 2 plus 4 times the cube of a number. So I need to pick a letter to represent the number. Most people pick x. So if I want to cube the number, I'm going to go x cubed. And then if I want to multiply it by 4, I'm going to put the 4 in front. So 2 more than 4 times the cube of a number. I could also write it as 4 times the cube of a number and then add the 2. They're the same thing. Letter B, the quotient of 5 less than a number and 12. So quotient means division of 5 less than. So notice here the words less than, because later on we're going to also see less, and there's a difference. A number and 12, pick, we'll say x, and so the quotient of 5 less than a number, that's going to go on top. So 5 less than a number is x minus 5. We're going to use a fraction bar to show division and then put the 12 on the bottom. Letter C, the square of a number increased by 4 times the same number. Square is a little 2. Increased means addition, 4 times means multiplication. So we're going to say the square of a number. So we're going to say x squared increased by, that's plus, 4 times the same number. So remember we used x to represent the number, so 4x. Letter D, 3 times the difference of a number and 8. So times is multiplication. Now when it says the difference of with times in front, that's going to tell you to use multiplication or parentheses. So we're going to do 3 times the difference of a number and 8. 3 times, and in parentheses we're going to put the difference of a number and 8. Alright, let's go the other way. So a mathematical sentence containing 1 or more variables is called an open sentence. Yes, we have sentences in math. A mathematical sentence stating that 2 mathematical expressions are equal is called an equation. So once you put that equal sign in there, you now have an equation. So example number 2 is having you go backwards. Take an algebraic sentence and write it into a verbal sentence. So letter A says 6x equals 72. So let's think. Well, 6x is the product of 6 and a number. Now to represent the equal sign, I can use the word is. It's the easiest way, 72. The product of 6 and a number is 72. If I look at letter B, n plus 15 equals 91. Well, I can say addition is sum. So I can say the sum of a number and 15 is 91. I could also say is the same as 91, is equal to 91, but is the easiest. Letter C, G minus 5 equals negative 2. So now I have subtraction. Subtraction is the fancy word difference. So I can say the difference between a number and 5 is -2. I could also say, why did I just write the word out? I could just put the number. I could also say is equal to the opposite of 2. There's lots of different ways you could write it. And finally, letter D, 2c equals c squared minus 4. So 2c is multiplication, so that's product. The product of 2 and a number. You could also say twice a number. The product of 2 and a number is, and then c squared is the square of the same number. So we'll say is the that number squared. And then we have a subtract 4, so we can say less 4. Again, this is only one way that you can write these, kids. There are lots of different ways you can write these. All right, so open sentences are neither true nor false until the variables have been replaced by numbers. So if you just have an equation, you can't prove it true or false until you plug something in for the letter. Like if you have x plus 2 equals 7, you can't say if that equation is true or false until you say x equals blank or x equals blank. Each replacement that results in a true sentence is called a solution of the open sentence. So the solution here would be x equals, not equals, x equals 5. So the reason why we can come to this solution is because of these things called the properties of equality. And these are things that you've learned about before, but you've probably forgotten. The first one is called the reflexive property. It says that if you have an equal sign and two things are on, and you have things on both sides, that those two things are equal. For example, look here, b plus 12 equals b plus 12. Notice that they're exactly the same. It's like you're looking at a reflection in the mirror. The symmetric property of equality says for all real numbers a and b, if a equals b, then b must equal a. So for instance, if 18 equals negative 2n plus 4, then negative 2n plus 4 equals 18. It's kind of like when you get to the end of a problem and you get negative 2 equals x, and you're like, no, let's write it as x equals negative 2. That's the symmetric property. The transitive property says for all real numbers a, b, and c, if a equals b and b equals c, then a equals c. This transitive property always has 3 parts to it. If 5p plus 3 equals 48 and 48 equals 7p minus 15, then 5p plus 3 equals 7p minus 15. There's always 3 chunks, and the chunks match up. The last property is a substitution property. It says if a equals b, then a may be replaced by b, and b may be replaced by a. Here's an example. If 6 plus 1, if the quantity 6 plus 1 x equals 21, then 7x equals 21. This is kind of like combining like terms. You're just trying to condense. Okay, let's see some examples of those properties on the previous page. Name the property illustrated by each statement. So letter A, if 3a minus 4 equals b and b equals a plus 17, then 3a minus 4 equals a plus 17. So notice you got 3 parts here. If 3a minus 4 equals b, and if b equals a plus 17, then 3a minus 4 equals a plus 17. This is the transitive property of equality. Adding the of equality is important because there are different properties later on, and so you want to learn to distinguish them. Letter B, if 2g minus h equals 62 and h equals 24, then 2g minus 24 equals 62. So notice they're telling you h equals 24, and then notice they're plugging that h equals into the equation for the final part. That's the substitution property of equality. You're substituting one value into the other in order to rewrite the equation. Letter C, if negative 11a plus 2 equals negative 3a, then negative 3a equals negative 11a plus 2. Notice that the same things are on the two sides of the equations, but they're swapped. When they're swapped, that's symmetric property of equality. All right, so we've got some more properties coming up. Solving most equations requires assuming that the original equation has a solution. The properties of equality allow for the equation to be solved by performing the same operations on each side of the equal sign. All right, kids, you already know these properties. The addition and subtraction property of equality. It basically says that if you have something like x minus 6 equals 14, then you can add 6 to both sides to solve the equation and you get the answer. You can also look at something like n plus 5 equals negative 32 and you can subtract 5 from both sides to solve the equation. You already know this. The second box is for multiplication and division properties of equality. For instance, if you have m divided by 8 equals negative 7, then you can times both sides by 8 and you can find your answer. Likewise, if you have negative 2y equals 12, you can divide the opposite of multiplication to both sides to find the answer. You already know these properties, you learn them in Algebra 1, you use them all the time. What I'm going to introduce to you is that, remember, this thing called a solution that comes out of an open sentence, and sometimes you have to see if it makes a true or false statement. So, solve each equation, check your solution. That's the new part in the directions. So if you're just trying to solve letter A, n minus 3.24 equals 42.1, you can undo the subtraction by adding 3.24 to both sides. Either line up your decimals or grab a calculator, but you get 45.34. N equals 35.34. Now that's the solve the equation part. The check your solution part is something you should do anytime you solve any kind of an equation. You should always see if it makes sense. Take that answer and plug it back in. So doing 45.34 minus 3.24, that's supposed to give you 42.1. Well, if I physically subtract these two, I do get 42.1. That's showing that you checked your solution. Do you necessarily have to write it down every time? No, but you should be at least plugging it back into your calculator to check and see if your answer is right or not. You can check your answers on your homework, but you can't check your answers on a test or a quiz. This is how you can. All right, letter B, negative 5/8 x equals 20. Well, we've got negative 5/8 x here. It's being multiplied, so I have a couple options. The first option is to divide both sides by negative 5/8. When you do that, you have to remember that when you divide by a fraction, you multiply by the reciprocal. And so dividing by negative 5/8 is the same as multiplying by negative 8/5. And then you can multiply across the top if you want to get 160, multiply across the bottom to get negative 5, divide it, and you get negative 32. That's one way. Okay, here's another way. Let's put it up here. Negative 5/8 x equals 20. Instead of dividing by negative 5/8, you can right away multiply by negative 8/5. And then when you multiply, you can put the 1 underneath the 20. And look, kids, you're right where I was before. So you get negative 160 over 5, which again gives you negative 32. There's other options that you can do as well, but I don't want to thoroughly confuse you. But what you should be doing is checking your solution. So to check it either direction that you solved it, you should be doing negative 5/8 multiplying by negative 32, and you should be getting 20. So if you multiply on the left side, you do in fact get 20. It checks, you know it's the right answer. Letter C, x plus 14.29 equals 25. This is an addition problem, so to undo, you subtract. If you do 25 minus 14.29, you get 10.71. So x equals 10.71. To check it, you want to do 10.71 plus 14.29, and you want to see if that equals 25. If you add the left side, you do get 25, and that equals 25. So you know your answer is correct. Last one, 2y equals negative 18. The left side is multiplication. To undo, you can divide by 2. You get y equals negative 9. To check, you would plug it in. 2 times negative 9, and you're supposed to get negative 18. You do, in fact, get negative 18 on the left side, so it checks. Okay, let's put some word problems to these. You can also use properties to solve an equation for a variable. So don't freak out. There's no geometry needed here. It's all algebra. Part A. The formula for the area of a trapezoid is area equals 1/2 height times the quantity base 1 plus base 2, where h represents the height and b sub 1 and b sub 2 represent the measures of the bases. Solve the formula for b sub 2. So notice I gave you a picture here. Base 1, b sub 1 is on top. Base 2, b sub 2 is on the bottom. The height is the perpendicular distance between them. And if I multiply the formula, I get the area. I want to solve the equation for b sub 2. I'm not going to plug and chug. I'm going to basically move stuff around to try to solve for b sub 2. So let's first write the equation over here. A equals 1/2 height times b sub 1 plus b sub 2. So remember, our goal is to get the b sub 2 alone, which means we have to get rid of the b sub 1, we have to get rid of the h, and we have to get rid of the 1/2. Well, the easiest thing to do is to get rid of the 1/2 first. So instead of multiplying by 1/2, you can multiply by the reciprocal 2 over 1. And now we get 2a equals h times the quantity b1 plus b2. Okay, looks a little bit nicer. Now I have two options. I can distribute the h to everything inside the parentheses, but that's going to really complicate things and make it a little bit more challenging. So why don't we get rid of it right away? It's being multiplied, so let's undo it by dividing. When I do it that on the left-hand side, I'm going to give myself a little bit more space. I'm going to leave it as 2a over h equals b1 plus b sub 2. Notice I can drop the parentheses now because there's nothing in front of the quantity. We're almost there, kids. All we have to do is get rid of the b sub 1. Well, to do that, I undo the addition of it and I minus it. So subtract b sub 1 from both sides. That's going to give me b sub 2 equals, and I use the symmetric property here to flip-flop what's on what side, 2a over h minus b sub 1. Notice one's a fraction, one's not. That's okay. But we successfully isolated the b sub 2. Okay, here's another one. This one's about a cylinder. The formula for the surface area of a cylinder is S equals 2 pi r squared plus 2 pi r h, where r is the radius of the base and h is the height of the cylinder. Solve the formula for h. Okay, so we're trying to get the h alone. So notice we have the height of the cylinder. Think of the cylinder as like a soup can. Height is top to bottom. Perpendicular distance to the radius is the center to the edge. So let's write the formula. S equals 2 pi r squared plus 2 pi r h. Alright, so I'm trying to get the h alone. That means I gotta first get rid of this big 2 pi r squared, and then I gotta get rid of the 2 pi r. So let's first get rid of this 2 pi r squared. Now it's a thing. They're all connected through multiplication, so I can move all of it at once to the other side. So on the left-hand side, I have s minus 2 pi r squared, and on the right side, I have 2 pi r h. I'm almost done, kids. I only have one more step, because the right-hand side is all being multiplied together, so I can divide by everything I don't need at the same time, 2 pi r. And I can divide the left-hand side by 2 pi r as well. Now, one thing I want to caution you, these 2's do not cancel, these pi's do not cancel, these r's do not cancel. Your final answer is h equals s minus 2 pi r squared over 2 pi r. They do not cancel. Because of that subtraction symbol there, they do not cancel. All right, one more slide. So there's often many ways to solve a problem. You can use the properties of equality to help you find a simpler way. I'm going to show you two methods here, one using the properties of equality, one not, and then you decide which way you like better. Part A, if 6x minus 12 equals 18, what is the value of 6x plus 5? Well, option 1, you can solve the equation for x, and whatever you get, plug it into 6x plus 5. So for instance, I could add 12 to both sides, get 6x equals 30, divide both sides by 6, get x equals 5. And then I could take that 5 in, substitute it. 6 times 5 plus 5, that gives me 30 plus 5, gives me an answer of 35. Option 1. Option 1 is to do that. Option 2. I'm going to rewrite the original problem, 6x minus 12 equals 18. Now my goal is to have 6x plus 5, and right now I have 6x minus 12. So think about what you could add to negative 12 to get 5. Well, you could add 17 to negative 12, and that would give you plus 5. And if you do that on the left, you also have to do that on the right. And oh my goodness, 18 plus 17 is 35. So whichever way your brain thinks about it, you get the same answer. All right, let's try another one. If 5y plus 2 equals 8/3, what is the value of 5y minus 6? Okay, let's show you both ways. You decide which way you like better. First way is to solve for y. So subtract 2 from both sides. 5y equals 8/3 minus 2 is 2/3. Divide both sides by 5. Y is 2/15. You can either do it in your head, or you can grab a calculator, or you can think of it as 2/3 times 1/5. Whichever you do, take that, plug it back in. 5 times 2/15 minus 6. That gives you 10/15 minus 6. That gives you negative 16/3. Use your calculator, simplify, find common denominators, like this is 2/3 minus 6. So that's negative 5 1/3, which is how you get negative 16/3. If you think about it the other way, so rewrite the original problem, 5y plus 2 equals 8/3. Now keep in mind you want minus 6. So what do I have to do to the 2 to get negative 6? Well, if I minus 8, 2 minus 8, that does give me negative 6. So I have to minus 8 on the other side. That gives me 5y minus 6 equals, and 8/3 minus 8 is negative 16/3 if you find a common denominator and subtract. All right, kids, that is the end of section 1.1. If you have any questions, please let me know. And as always, keep calm and keep trucking.